Om Shri Sai Ram. Welcome to the computer science class. Today we are going to start a new chapter, that is pointers. This is the video part 1 of this chapter. Pointer is such an interesting concept in C++. You will have a fun while learning the pointers. Some of the C++ tasks can be done very easily with the help of the pointers. But before going to the pointers in detail, we will just jot it down that what are the concepts we are going to learn today. First, we will clarify some memory concepts. As pointer deals with the memory addresses, so our concepts of memory should be clear. So we will see the basics of memory concepts. Then we will see what is pointer. Then how the pointers are represented in memory, that we will see with the help of some pictorial representation. Then we will see how to declare a pointer in C++, how to initialize a pointer, and then we will see what are the advantages of pointer. So let us begin. So first we will have a look over the memory concepts. It is very important to understand the memory concepts. We know that computer memory is mainly categorized into two categories, primary memory and secondary memory. Our files are stored on the hard disk drive or the solid state drive. This may be a new terminology for you, solid state drive. What is solid state drive? Solid state drive are nothing but these are also a secondary storage devices, but they uses the flash memory to store the data. This is the integrated circuit assemblies to store the data persistently. We may sometimes call it as a solid state devices also, or solid state disk, even though they do not have the disks or the read write heads, just like the way we have hard disk and the flash memory. But basically we store the data permanently on hard disk drive or some solid state drive. But these drives are just used to store the data. These are just the storage houses, just like godowns. We cannot work on the data in the file which are stored on these storage devices. So we have to move the data from the secondary storage device to the primary storage. What is our primary storage? Our primary storage is a RAM, random access memory, that we all are aware of with that. So memory, so from here onwards, whenever we say the memory, means we are addressing to the RAM, random access memory. In old days, the memory was of size 512 MB. Because that time there were not much complex applications and the processors are also of low capacity. So with the 512 MB memory, the computers were very much efficient to use with the computers. And then this memory is basically a huge array of 8-bit wide cells. Means we can logically picturize the memory as cells. Each cell size is 1 byte wide. So 1 byte comprises of 8 bits. We know bit means binary digit 0 and 1. So every computer has a primary memory, that is RAM. If a computer do not have RAM, even we cannot start the computer itself. So RAM is required. Then all the data and programs we need to bring it to the RAM in order to process. In hard disk we cannot process the data. And then the primary memory of computer consists of number of cells. One cell which can store 8 bits of data, 0 and 01. Then each cell is capable of storing 1 byte of data, as well as each cell is numbered, and we call this number as the address of a cell. And these addresses are in hexadecimal form. So this is the process where we can manipulate our data, we can execute our programs. So this concept is very much clear, that we cannot process or manipulate the data which is stored on the hard disk. We have to bring that data into the RAM, and then there we can process. So there is a direct interaction between a computer program and the data in RAM. In fact, the computer program which is under process, that will also be in the RAM while processing. That will not be on the hard disk. So when we declare a variable int x like this, what happens in the computer memory? The computer allocates the space for this variable in the memory and associate this name x with that particular memory cell. And when we try to access that memory cell with the assignment statement like this, x is equal to 36, that means we are referring to that memory cell which is already created in the memory. So when we refer like this, or whether we want to perform some arithmetic operation on the data which is already stored, or we want to output the value, in any way if we want to refer to the memory cell, computer must take two steps. First one is what? It look up the address that the variable name corresponds to, at what address, to which address this name is given. And second, go to that location in memory and retrieve or set up the value it contains. Either we want to retrieve the value for printing purpose, or for using that value in some arithmetic operation or in any other operation, or we want to print the value onto the screen. For any purpose, we are retrieving the value from that memory cell. Let us look at the picture over here which explains that how a computer memory stores the data in bit format. So here, as we said earlier, that a computer memory is nothing but a huge array of 8-bit wide cells. Huge array. We know what is array? Array means the collection of elements, group of elements. Here array means the collection of cells, contiguous cells. So we can picturize the memory as array of cells. So here our variable x, when we declare the variable x, what does a computer do? Computer attaches this name with some memory cell. This is a memory cell, and this memory cell is numbered. This number is nothing but the address of memory cell. So this cell is having address 200, this cell is having address 201, 202, 3 and 4. And each cell can store 8 bits, that is 1 byte. 8 bit means 1 byte. So when we say x, we can call it as a tag. Tag attached to a particular memory cell or to a particular memory address. We call it as a user defined name in C++. And this is a memory address. So you can see here, with the statement x is equal to 36, we want to store 36 in binary form. What does a computer do? Computer converts our decimal number into binary form. We have studied in first PU how to convert the decimal number into binary form. So by using that mechanism, computer runs certain algorithm, certain program and converts the number into binary form. You can see here the number 36 is represented in binary form. For your sake, you can see here this value which represents 36. So this bit represents 1, this bit represents 2, this bit represents 4 and this bit represents 8, 16 and 32. So if you add 32 plus 4, it is 36. So 36 is represented in bit form, binary digit form, binary representation of 36. But you can see here what these other bits mean. So many zeros are here. What is the need of these zeros here? Yes, because whether A computer is allocating 2 bytes of memory or 4 bytes of memory, that depends on the computer type we are using, the processor type, whether 32 bit or 64 bit. And every data type, whether it is an integer data type, character data type or float data type, it consumes certain bytes of memory, that is fixed. So here integer is consuming 4 bytes of memory, that's why this number is represented into 4 bytes. So we cannot leave these spaces blank. That's why instead of leaving blank, we have attached the 0 in the beginning, which do not affect the actual value of the data. Actual value remains the same, these zeros will not affect this one. So this way we are filling the data in the all the 4 cells. So a question may be arising in your mind that this is a wastage of memory. Yes, because every data type, int data type or character data type or float data type, that data type is for a certain range of value, that represents certain range of value. For the sake, if a integer variable consumes 2 bytes of data, that means it is capable of storing the value in the range minus 32768 to plus 32767. In this range it can store the value for the 2 byte, and for the 4 byte it is a more lengthy value. So each data type represents a certain range of values. Till now there is no data type, no such mechanism in C++ for a particular value. So it is for a particular range of values. So here we don't have a solution that these are the wastage of bytes. So these are the data sizes we have learned while learning the C++ programming language in the beginning. Int consumes 4 bytes, char consumes 1 byte, float consumes 4, double 8 and then long 8, and these are the things, these are the points, these two data types are of our interest. These represents the pointers. String, actually there is no string data type, there is no data type such as string in the C++. Generally we call the string as character array. So whenever we want to represent the string, we have to declare the character array, and in C++ the strings are handled with the character pointers mainly. So that's why here character pointer, this star represents a pointer that we are going to learn. So this also consumes either 4 or 8 bytes in memory depending on the type of processor we are using. And the int pointer, float pointer, double pointer or any other pointer, a pointer to a class, pointer to a structure, that also consumes the same amount of memory. So this is just a overview for you that each data type consumes certain amount of memory in the computer, and mainly this pointer, which is of our interest today, which consumes either 4 or 8 bytes in memory. As we said, a memory is an array. So that's why we will see here what happens when we declare different types of variables and we want to store the different types of values in this array of cells. We call it as a memory. So here a memory is represented as an array, as a contiguous series of locations. And we know that array always begins with the 0. So this 0, 1, 2 up to 19, these represent the addresses of the memory cells. But actually the addresses of memory cells will be represented in hexadecimal form. So it is just for the sake of our understanding. So when we declare a variable C, which is of type char, and assigns a value h to it, here a character variable takes only one character value. So that's why we are assigning one character value which is enclosed in single quote. So immediately a computer allocates a 1 byte to the h. So suppose it is allocated the location number 4 here. So that is not in our control, which location, which memory cell the computer will allocate to a particular value. That depends on the memory allocation system. and when we declare a integer variable and stores the value 65, computer will allocate the 4 bytes. So here you can observe that integer data value and the character value are not allocated the contiguous memory locations adjacent to each other, because whenever a computer memory allocation algorithms are executed, they are designed based on the concept that the contiguous memory locations should be utilized. Memory location should not go west, because whenever there is a demand for a big data size in the memory, the big data size, big data computer memory locations should be available in the memory. So we will not go in detail at this point, just we have to understand that when we declare one variable, it allocates 1 byte of memory, when we declare another it allocates, but it is not sure that it will be allocated contiguous, that is not in our control. So as we have discussed, the data value h or the 65, they will not be represented as it is in the computer memory, they will be represented in binary form. So h is represented in binary form and 65 also represented in binary form. So h, we know that all the alphabets or all the characters on the keyboard have some ASCII code. Then that ASCII code will be converted into binary value. So h is having some ASCII code which is converted into binary value, and this binary value also will not be stored into this merging of cells, merging of 4 cells into one cell. They are allocated a cell of 8 bits each. So this value will be divided into 8 bits. So actual representation would be like such. So it is just our imagination. And when we again allocate another type of value which is of string, that is character array. So one character value is allocated memory here, then some space is left, and then integer value is allocated a space, and then after that character or the string array allocated a space. So that while allocating the memory, computer takes the present scenario of the computer memory in consideration, and then accordingly it allocates the memory. So we should not bother about it. So the addresses are represented in hexadecimal form. So if you have understood these memory concepts very well, these basics only, that how does computer allocates the memory to our data value in computer programs, then we can now ready for the understanding of concept pointers. In simple terms, we can say pointers are nothing but just addresses. Pointers are nothing but just addresses. Why I am saying this? Just look at it. A pointer is a data item whose value is a memory address. Because a pointer represents some memory address, that's why we call it as pointers are just addresses. And the type of the pointer describes the data located at that memory address. Means computer stores the memory address, and the type of a pointer means what? We can know that at that memory address what type of value is stored. Means if a pointer is of type int, that means definitely it is storing the address of integer memory location. Pointer allow data structures or variables to be shared among functions. So this is actually the use of pointer, which allow us to data structure or variables to be passed between the functions. Pointers make a computer environment more like the real world. So if you start working with the pointers, then you will come to know that how it is easy to manipulate certain data items, certain data structures with the help of pointers. So we will feel just like that we are manipulating the real world objects. So keep this image in the mind where a memory cell is named as K with int K. When we write int K, a name is attached to a memory cell, and then when we write K is equal to 5, the value 5 will be stored in the memory cell where the K is attached. And as we said, this memory cell is having certain address. What is this? This is the pointer declaration, int star pk. So here there is no difference in these two lines. Here also int k, here also int pk, only we are using the star. Star means it states that this is the pointer. And when we, same thing, as the memory cell is allocated to k, then a memory cell is allocated to pk. And when we write pk is equal to ampersand k, this ampersand is the address of operator. That means we are assigning the address of k to the pk. That means this value we are going to store in pk. This is the meaning of these statements. So that means we can say that pk is made point to k. pk is pointing to k, or we can say pk is a pointer to k. This is the meaning of these statements. So here we have noticed the use of star operator. We call it as a dereference operator. What is this operator? The main purpose is to dereferencing the pointer. Main purpose is to dereferencing the pointer. Means whenever we want to refer to the value which is stored at the address to which the pointer is pointing to, we can access that value with the help of this star operator. So if we have a pointer to char called PC, then star PC is the data that lives at the memory address stored inside the variable PC. So star is known as the dereference operator. So it goes to that particular memory location and access that memory location, access the content stored at that memory location. So star is used to dereference the address, as well as it is used while declaring the pointer variable. So this is the syntax for pointer declaration. Data type star and pointer name. Example int star p int. So the names of the pointer should follow the naming conventions that we have learned for naming a variable. There is no change. Here when we write this in memory, what is happening? There is the memory cell allocated to p int, and this is one integer data 574. So this pointer is pointing to this 574. Here the star operator is also called as the declarator operator or indirection operator or dereference operator. And when you declare the pointer, you can declare in any of one of these three ways. All the three ways are equivalent. That means you see the position of this star while declaration. Here the star is attached to the data type. Here the star is in between these two things. One is the data type, another one is the pointer name, or you can attach the star to the pointer name. So all the three statements are valid. But if you want to declare multiple pointers of the same type, you cannot use the line like this. You cannot declare like this, that only you are writing int star and then you are giving the different names, the way we declare multiple variables of same type. You cannot declare the pointers in this way. So the correct declaration should be like this: int star px star py star pz. Means with every pointer name you have to attach, you have to prefix the star operator, that is dereference operator. So these are the various pointer declarations. The way of declaration of a pointer for various data type is same, whether you want to declare integer, float, unsigned, char or point. One more pointer you can declare here that we never declare with the data types with the simple variable is the void pointer, void star pointer. What does this mean? That means this pointer can now bind to any type of value. As we discussed that integer pointer can hold the address of integer variable, character pointer can hold the address of character variable, float can hold the address of float variable, but if you declare the void pointer, it can hold the address of any type of variable. Means it can point to any type of memory cell. Next one is pointer initialization. That means assigning the address value to the pointer. It is very simple. Assignment operator, address of operator and the variable name of which you want to assign the address to the pointer. So p int is equal to address of num. So consider that num is allocated one memory cell in the memory whose address is 23014 and we have stored the value 574 over there, and we have declared the pointer p int which is allocated one memory cell, and with this statement we are assigning the address of num. That means p int is pointing to this address. So this address will be stored at the memory cell p int. Address extraction operator. Pointer variable we can declare with the help of ampersand also. Actually the ampersand we call it as the address of operator. So if you want to know the address of any variable, we can get with the ampersand operator. So here there is a demonstration that if ARR is an array of doubles, then address of ARR of I is a pointer to double. So with the help of ampersand operator, you can make a pointer like that. So this statement is pointing to that the ith element of ARR. So here actually what we are doing, we are just accessing the address of that particular location. Now we'll see the program, complete program which demonstrates the use of pointer. In this program what we are doing, simply we are declaring one integer memory location, one integer pointer, and then we are allocating the value to the integer variable and we are assigning the address of this integer variable to the p int. Here we are printing the value of num, simple statement, and we are printing the address of num by using the p int. So this is the value which we have printed by using the num, and the address of num which is stored in p int that we have printed here. Now what happens when you write star pk is equal to 35? This is the another notation. This thing we have seen, m is equal to 4 is simple thing, m is equal to 4 is a simple that we are storing the value 4 at the location m, but star pk is equal to 35. So this is the data value, right? But this data value we are not storing at pk. What? Because pk is a pointer and which can hold only address. So pk is pointing to this address. So the meaning of this statement is that pk is pointing to the address of k, so we want to store the value 35 at the address of k because pk is having the address of k. So with this operator, dereferencing operator, we can store the address in k. But here what we are doing, we are creating another variable m and assigning the value. So there is no big deal in these two statements, created one variable and assigned the value 4. But what we are doing here, we are assigning the address of m to pk. So earlier we had assigned the address of k to pk, now we are assigning the address of m to k. So pointer is only one. First we assigned the address of k and now we are assigning the address of m. So what will happen here? Just think. Here pk which was pointing to k, it will be dereferenced, means it will no longer point to the k and then it will point to m. Simple thing. It is as simple as that. Suppose here we have declared one variable, take the example same, int m is equal to 4, and after this if I am writing m is equal to 10, then what is happening? Instead of 4 it will store the value 10. So now pk earlier was storing the address of k, now it will store the address of m. It is as simple as this. But at one point it can point to only one variable. It will not happen that at the same time it is pointing to both the variables. It can point to one variable and of its type only. You cannot do like this, that here you are trying to assign the address of float to the pk. If m is the float type, so you cannot assign. It will be the type mismatch. Computer will give the error type mismatch. So same thing we will see here. So this part is same, one integer variable declaration, one integer pointer declaration, and 45 is we are assigning to the num, and address of num we are assigning to p int. So here we are seeing the different ways to work with the pointers. This is just simply we are printing the value of 45. Now this is the new thing for you. We are using a star, a bracket, then address of, and then num. So if you try to understand the part by part of this expression, you can see address of num. So what we are doing here? We are accessing the address of num variable, and star means what? It is a dereference operator. So we want to access the value which is stored at that address. So that's why this statement also printing the value 45. So this statement and this statement is almost same. And here star p int. Here also what we are doing? We are dereferencing the address. So here also it is printing the value 45. So you can see this statement and this statement also same. This is also dereferencing the address, and this is also dereferencing the address, because address of num is address and p int also represent the address. So this bracket and ampersand is replaced with the pointer only here. And address of num we can print with the address of operator, and pointer also having the address because it is allocated a memory cell. So if you want to know the address of pointer, the mechanism is same, use of the address of operator, so address of pin. So you can print the address of any variable with the help of address of operator. Now the same program is picturized over here. We have created p int and then we have used the address of. So both are representing what? This address of num. This is the num variable. P int also referring to the same address, and both are dereferencing the same address. So this address is here, and this is the address of pointer which we have printed, and here address of num variable, same thing, num, it is representing the num, star p int also representing the 45 value, and star ampersand num also representing the value 45. So here just a picturization of whatever notations we have used to access the address of pointer, to access the address of num, or to access the value which is stored at 45. Now we have to be careful when we are dealing with the pointer, which are the valid expressions and which are not valid. So here there is an error. This is int a, no problem. Then this is int p int, and p int is equal to a. So if you execute a program, there is no problem in this. At this point there is no problem. The meaning of this is you want to declare the integer variable a, you want to declare integer variable p int. But the moment you try here p int is equal to a, then also no problem, because whatever the value of a, that will be assigned to p int. But if this is there will be a logical error here. If we want to assign the address of a to the p int, then p int must be declared as a pointer. Otherwise, there is no syntax error in this particular statement. But whatever outcome we are expecting, that we will not get here. So we have to declare it as a pointer. And here what is happening? What is we are missing in this statement? This is okay, no problem. Here we are declaring the float pointer, there is no problem. But p float is equal to x, this will be error. This will give you the error. Compiler will give you the error, because the value of x is some data value and pointer can store only the address. It cannot store the address. So that's why this line will give you error. We want to allocate the address of x to the p float. That's why here we have to use the ampersand sign. We have to use the ampersand sign here, and here we have to declare it as a pointer. In this case, what is the problem? Here we are making a mistake. We are assigning the address of n to the pointer before the declaration of the variable. This will be a problem. First you have to declare a variable, then only you can assign the address of variable. So here just you have to change the sequence of the lines of code. And here what is the problem? As I already told, an float pointer can point to float, integer pointer can point to integer. We are trying to assign the address of integer variable to the float pointer. And here also we are making mistake, we are not using the address of. But even though if we give the address of operator, it will give you an error, because this is an integer variable and this is a float pointer. So you keep in mind that these mistakes we should not make while working with the pointers. This is very important concept, null pointer. Null means we know nothing, means it is not representing any kind of value. See, what is the use of pointer? The use of pointer is to store the address of any other variable. So if we are declaring a pointer and not assigning the address of any variable to that pointer, that means it is not referring to any memory address, then what will happen to that pointer? It will simply remain as a dangling pointer. We call it as a dangling pointer, a pointer which is not pointing to anything. So if a pointer is not pointing to anything, what is the use? So better, instead of leaving it as it is, you can allocate a value null, or instead of null value you can allocate 0, so that it will not cause any problem, it will not be a dangling pointer. So you can understand that this pointer is not pointing to any variable, it is not pointing to any address. And you can check with the equality operator, with the comparison operator, whether pointer is pointing to some memory address or whether it is a null value, it is representing a null value, means it is not pointing to any address. So if you understood very well the memory concepts, then how to declare a pointer, how to initialize a pointer, what are the different notations, what are the different operators. But definitely will ask a question, what is the advantage of a pointer? If I can access the memory location directly and I can get the address of the memory variable with the help of ampersand operator, then why shall I use the pointer? Why shall I increase the overhead of the memory by creating a pointer and again increase the line of code and adding the complexity in my C++ code by using the pointer? If you see the list of advantages that pointer provides, then definitely you will love to use the pointers. Pointers save memory space. How? We have seen, whether it is an integer pointer, whether it is a character pointer, or whether it is a class pointer. It consumes same amount of memory, that is either 2 bytes or 4 bytes. Now, and this one, at this point I have mentioned this advantage, but you will come to know when we study the use of pointers with arrays, functions and strings as well as structures and even the classes also, that how easy it will be to work with these complex structures by using the pointer. So it will be very easy. It allows the pass variables, arrays, functions and strings as function arguments. We have up to this point, just we have seen we can pass the function arguments by the value. Then execution time with pointer is faster because data are manipulated with the address, that is direct access to the memory location. That's why you can access the data very fast. Now it provides functions which modify their calling arguments, that is we call it as a call by reference, that we are going to study in the next part of the video. And then it supports dynamic allocation and deallocation of memory blocks. This part also we are going to see that how a pointer is used to allocate the memory dynamically. Dynamically means during the runtime of a program. Then pointers are used to create complex data structures such as linked lists, tags, queues, trees and graphs. So data structures we have studied in chapter 4. So these pointers are used to work with data structures, such data structures very efficiently. Then for the file handling, pointers are used. So most of the file operations are based on file. Then manipulate complex data structures efficiently even if their data is scattered in different memory locations. Yes, this is very easy. If data is scattered at different locations and if you declare a pointer and pointer can directly point to the addresses, then the data will be accessed very fast. And then use polymorphism, that is calling functions on data without knowing exactly what kind of data it is. So polymorphism, that means in case of overloading, a function having different forms. So if you use the pointers, then calling of the functions will be very easy. So hope all of you have understood the concepts of memory, then the use of pointers, how to declare it and what are the different operators, and definitely by looking into the advantages and some new terminologies and new concepts in the advantages, the interest definitely have been created in your mind to know more about the pointers, that we will come to know in the coming part of the video. Thank you. Sai Ram.